In 5.3 video, we're going to be doing some more graphing with stating the domain and range. Here we have a graph of 6 over x squared plus 1. And all you're going to do is type in your calculator everything you see here, but making sure that you put parentheses around the bottom. When you do that, your graph should end up looking like this. And when we go to do the domain and range, first of all, if you look at the left and the right side for domain, we're talking about the x values here, the graph is on both sides. So that just means all real numbers. When we're talking about the range, we're looking at the top and the bottom. Obviously, the graph is only on the top, so it has to stay above a certain number here. But instead of writing it like the y is more than one number, these are actually wrote a little bit different. Y is actually going to be between two different numbers. And if you go to your x and y chart, we have a whole bunch of different numbers. And it might be a good idea for you to write these down just so you can understand the range for these graphs. Okay, now that I have all those down, as you can tell, it's almost looking like a mirror image on each side of the graph. This is the peak of this graph over here. And you can tell where that peak is. Okay, so what we're going to do is we're going to say that the graph has to stay between something and 6. If you notice on either side of 6, all these numbers are getting closer and closer to 0. And all these numbers are doing exactly the same thing. They're getting closer to 0. So this y is supposed to stay between 0 and 6. And we're going to say the y has to be more than or equal to 0, because here you can tell that there is an asymptote that this graph is staying above, which is 0. But it never goes past 6. It reaches 6 and then it goes back down. So it has to be less than or equal to 6. So that is how we're going to do the range for these type of problems. All right, another problem you're going to be doing in the book says identify the x-intercepts and the vertical asymptotes of these graphs. So the good news is that you're no longer graphing these. You don't have to state the domain and range. We're just going to point out the x-intercepts and the vertical asymptotes. Now, the way to figure out the x-intercepts is to look at your numerator. So if you look at the numerator and you set it equal to 0, obviously that doesn't make sense. You can't solve it. So there are no x-intercepts for this particular problem. And you're going to write no x-intercepts. Now when you're looking for the vertical asymptotes, you have to look at the denominator and do the same exact thing. So we're going to put x squared minus 1 equals 0. And we're going to solve for x. So we have to add the 1 over and then take the square root. And remember, it's plus or minus 1. And so the vertical asymptotes, and you're going to write that, vertical, and that means it goes up and down. Asymptotes are at x equals -1 and x equals +1. If you look over at number 2, we're going to do the same exact process. First, we're going to figure out if there's x-intercepts. So you look at the numerator. We're going to set that equal to 0. And when you do that, we're going to subtract the 9. And you're going to take the square root of both sides. Now, when you take the square root of a negative number, it comes up air in your calculator. You should know in your head that you can't take a square root of a negative number. So again, this one will have no x-intercepts. Okay, now we move on to the vertical asymptotes, and that tells us to look at the denominator. We're going to set that up as well. I'm going to do it above here so I have room. Now you could do this a couple different ways. You can go to your y equals and plug x squared minus 2x minus 15 and go to your x and y chart and find where the zeros are. That's what I did for this problem because it's very easy to do. You could also factor this. You could plug it in the quadratic equation, whatever method you want to do. So I did the x and y chart, and I found that at -3, y equals 0, and then at 5, it equals 0. So the vertical asymptotes, I'm just going to do that, is x equals -3 and x equals 5. Alright, here's another problem. Same exact process. We're going to find the x-intercepts. So we look at the numerator and we set it equal to 0. So we're going to subtract the 27. And we're going to take the cube root. Now, when you take a cube root of a negative number, it is possible. When you plug that in the calculator, you get -3. So -3 is the x-intercept. So for this one, we actually found one. Okay, now we move on to find the vertical asymptotes. And we set the denominator equal to 0 this time. And again, you can either factor this out or you can set it into your equation, into your calculator. I found that when I set it into my calculator, I could not find the other 0. And that just tells you that maybe that other 0 is a fraction. So in this case, I would want to use the quadratic function or just factor it. And for me, factoring is a little simpler. You're going to pull out the like term, which they both have at least an x, and you're going to write what would be left over. Once you have it factored, you have to set each one of these items equal to 0. So x equals 0, which is already solved, and then 3x minus 1 equals 0. So then you add 1 to both sides and divide by 3. So x is 1/3 and x is 0. See how this one was a fraction. So the vertical asymptotes are x equals 0 and x equals 1/3. Now we keep talking about the vertical asymptotes, which on a graph, you know that the vertical asymptotes are all of the lines that go up and down. But what about the horizontal? The horizontal ones are the ones that go across. There is a way to find those as well. And we have this equation here that says the leading coefficient of the numerator divided by the leading coefficient of the denominator. And you can do that as long as the degrees are the same. So if you look at this problem down here, the degree of the numerator is a 2, and the degree of the denominator is also a 2. So we can follow this equation. The leading coefficient of the numerator is 2. And the leading coefficient is 1 in the denominator. So if you divide those, you get 2. So the horizontal asymptote, and remember it's no longer x equals, it's y equals. That would be the horizontal asymptote.